Welcome to this explainer. Okay, today we're diving into something super fascinating and honestly incredibly relevant happening right now in the world of artificial intelligence. We're looking at the story of Davey Hoogland. He's an independent AI researcher, and he's been on this absolutely relentless, self-taught mission to validate a truly groundbreaking compliance tool. Seriously, if you've ever wondered what actually happens when a massive tech breakthrough comes from outside the traditional, closed-off academic system, well, that's exactly what we're going to unpack today.
Let's kick things off with a quote straight from the source material that really sets the stage. It says, "Innovation doesn't require an institutional pedigree." We so often just assume that major technological leaps, especially when we're talking about incredibly complex stuff like AI alignment and data privacy, can only come from well-funded university labs or massive corporate giants. But as you'll see in just a minute, sometimes the most profound, truly actionable solutions emerge from the periphery. They come from independent outsiders who, frankly, just refuse to accept the status quo.
So let's look at part one, the breakthrough, and the power of independent innovation.
Okay, let's dive into this. At the very core of Davey's work is this methodology called context engineering. Now, in a tech world where AI almost always operates like a mysterious black box, constantly requiring us to send our highly sensitive data off to centralized cloud servers, context engineering does the exact opposite. It completely flips the script. It enforces something called trust by design. By using an architecture based on zero server-side storage, the intelligence is actually brought locally to the data. It enforces client-side sovereignty. Basically, this means compliance and logical rules are totally guaranteed without your data ever having to leave your own secure environment. It's a real game changer.
Now, you might be wondering, how did this innovation actually come about? Well, it didn't start with a traditional grant-funded hypothesis, that's for sure. It started with a glitch, an anomaly. Davey has a really unique autodidactic background. He describes himself as a philosopher builder. Actually, he's a certified welder turned independent researcher. And he observed this strange copyright anomaly while working on some aging, deprecated hardware. Honestly, standard institutional filters probably would have just completely ignored this little quirk. But his practical, hands-on mindset? It sparked what he calls a continuous research loop. He just followed the data, and it led him straight to a major architectural innovation.
Moving on to part two, let's talk about the tangible value of this work, specifically when it comes to regulatory compliance.
Now, what's really interesting here is the empirical proof. It's pretty striking. In a stress test of his functional prototype, which acts as a compliance auditor, the system flawlessly identifies critical regulatory violations. For example, when it's fed a complex scenario about using biometric emotion recognition during a hiring process, the system deterministically flags it. It points right to Article 5 of the EU AI Act and says, nope, prohibited practice. It also accurately catches GDPR Article 22 violations regarding automated decision-making and even spots unauthorized data transfers to the US. And get this, it does all of this with 100% accuracy. No hallucinations, no storing of the raw data, the whole shebang, completely secure.
And crucially, we need to understand that this isn't just some theoretical white paper floating around. This intellectual property is officially registered. It holds a DataSure Certificate of Anteriority and has official registration with the BOIP. So this is scientifically structured, legally safeguarded work. It is a fully functioning empirical prototype that holds massive value and is absolutely ready for market validation right now.
Which brings us to part three. The institutional wall and the reality of bureaucratic gatekeeping.
So trying to do things the right way, Davey systematically approached a staggering number of established entities to get this vital work validated. Just mapping out the timeline, in late 2025, he reached out to TNO. By early 2026, he's contacting JADS and reaching out to AI experts at the University of Vienna. Come March, he applies to the Dutch AI Regulatory Sandbox and contacts the EU AI Pact. And by April, he's submitting massive, comprehensive technical dossiers to the European Joint Research Center. I mean, it is just a relentless, proactive effort to bring this highly valuable innovation out of the private sector and into the public domain where it can actually help people.
Let's look at part four, systematic blockades, or as I like to call it, the intense friction of the academic world.
This next comparison perfectly captures the bizarre disconnect he faced. On one hand, you have Davey's highly technical, incredibly detailed submission to the EU Joint Research Center. He's literally offering a concrete architectural solution to the exact problems the EU AI Act is desperately trying to solve. And on the other hand, a dismissive, totally boilerplate advisory response from Your Europe Advice. They basically tell him, hey, we're just an independent advice service, we can't actually help you make any progress.
It's wild. It's a profound working technical solution crashing headfirst into a standard, unyielding bureaucratic wall.
And this next exchange brilliantly illustrates the academic wall. This is correspondence with TNO. Davy is offering them an empirical case study and a working, tangible prototype. You can literally test it. But the response? It's this incredibly rigid deferral to standard, disciplined peer review processes. They completely miss the immediate practical value of the software prototype that's sitting right in front of them. It's like the institution only knows how to process information if it comes packaged in their exact, traditional, theoretical format.
We see the exact same pattern repeat with the VU Amsterdam. In these emails, the professor involved actually states he was genuinely intrigued by Davy's ideas. But the very moment the conversation turns to sharing the actual code files for a proper review, boom, the institutional friction takes over. The strict requirement to involve university legal teams just to sign non-disclosure agreements creates this absolutely impossible, and I quote, uphill battle. And this is for an independent researcher who is literally just trying to share a functional solution.
So what does all this mean? Well, it reveals a profound systemic disconnect. On one side of the ring, you have independent innovation. It's empirical, it's agile, and it is hyper-focused on building verifiable working prototypes. On the other side, you have academic gatekeeping. It's purely theoretical, it's painfully slow, and it is entirely obsessed with traditional pedigrees and red tape. The system just simply lacks the flexibility to embrace a philosopher-builder who wants to skip the endless theoretical discussions and just deliver real, functioning code.
Even when trying to go the route of scientific publishing, the methodology hit a brick wall. As the sources show, his manuscript was actually initially accepted by 4 different reviewers at Springer Nature. That's a huge deal. But then, well, then it got caught in this chaotic, endless cycle of journal transfer services. It was plagued by technical duplicate errors on their end, and ultimately it stalled entirely because of, you guessed it, rigid institutional affiliation requirements. But you know, it's absolutely crucial to view these roadblocks not as defeats, but as inevitable friction. It's basically the price of admission for trying to introduce true independent disruption into a very closed system.
Now let's move to part 5 and see how this builds, opening a new door through a major strategic pivot.
Davy clearly recognized these systematic blockades for exactly what they were, so he made a massive strategic pivot. He moved away from trying to satisfy academic theory, and instead, he decided to prove his work on the tech industry's own massive empirical infrastructure. He applied directly to the Google for Startups cloud program. His autodidactic mindset kicked in. If the traditional doors of the establishment slammed shut, well, you just find a way to force a brand new door open in the industry, somewhere the sheer value of your work can speak for itself.
And honestly, the receipts for this pivot are undeniable. Just look at the progress here. We have his official application to the Google Cloud program proudly registering as an independent researcher. And right alongside it, the triumphant acceptance email from the Google Cloud team. Welcome to the program. I mean, what a shift. This represents a massive leap from standard bureaucratic rejection to genuine, tangible industry recognition.
So the crucial point is this. The journey culminates in a strategic proposal to the Google research team. Davy is taking his startup program acceptance and using it to pitch a bold, collaborative effort. He's essentially asking Google to officially validate his deterministic AI compliance framework by stress testing it on their Vertex AI infrastructure. He took his highly valuable, undeniably innovative work, and when the old guard wouldn't listen, he just went ahead and built his own powerful alternative avenue to get the official validation it so clearly deserves.
This entire journey really leaves us with a powerful final thought to chew on. The established system just isn't always built to recognize value when it comes from the outside. But as Davy Hoogland's incredible story shows us, when the heavy doors of the established order close right in your face, how do you break open your own doors? How do you champion your own valuable work? I really hope this explainer has given you a fresh perspective on what independent innovation actually looks like in the trenches. Keep questioning those black boxes around you. And hey, thank you so much for learning with me today.